Let's do something unusual. Let's talk about light, but let's pretend we don't already know what light is. No waves, no particles, no photons, just you and the experience of light. Because the moment we jump to the answer, we miss the most interesting part, why this question was so hard in the first place. Now, here's the first honest question. Is light a thing, or is it just something that happens? That question sounds simple. It isn't. Most early thinkers reasoned like this. If something affects my eyes, then something must be traveling from the object to me. That feels reasonable. You throw a stone, it travels. You hear sound, something travels through air. So light must also be something moving. But then confusion appears. Light has no weight. You can't catch it. You can't bottle it. It moves incredibly fast. So what kind of thing is this? Newton said, light is made of tiny particles. This solved many problems. Straight line travel, reflection, sharp shadows. Very convincing. But then something strange happened. Light bent around edges. Light made patterns, fringes of brightness and darkness. Particles shouldn't do that. If you throw stones through two gaps, you get two piles. Light didn't behave like that. Instead, it made interference patterns. Now the honest thinker must pause. If light is a particle, why does it behave like something spreading? So others said, fine, light is a wave. Waves explain interference beautifully. Water waves do this. Sound waves do this. But waves need something to wave in. Water waves need water. Sound waves need air. So, what is light waving in? Scientists invented something called the ether. Invisible, everywhere, undetectable. And here comes intellectual honesty. No one could ever find it. Every experiment to detect the ether failed. At this point, the situation looked bad. Particle theory explains some things. Wave theory explains other things. Neither explains everything. Both contradict each other. This is where most textbooks skip ahead. But this confusion is the heart of science. Einstein didn't try to choose. He did something more disturbing. He said, light behaves like particles in some experiments and like waves in others. Not metaphorically, literally, which sounds like cheating, but here's the deeper move. Einstein wasn't describing what light is. He was describing what happens when we measure it. This is subtle and crucial. Richard Feynman later explained that the wave is not the thing. The wave is the math of probability. Let's slow down here because this sentence is doing a lot of work. When we say wave, we instinctively imagine water rising and falling. When we say particle, we picture a tiny marble flying through space. But those pictures are not reality. They're metaphors our minds reach for, because we don't have better ones. Light is not a wave the way water is a wave, and it is not a particle the way a stone is a particle. Those are human ideas, borrowed from everyday experience. What actually exists is stranger and more abstract. What exists is a quantum event, a structure of possibilities, a rule that tells nature what can happen and how likely each outcome is. When light travels, nothing tangible is moving through space the way a ball moves through air. There is no tiny object racing forward. There is no ripple spreading through a medium. What moves is possibility. And then, suddenly, when light is detected, something real happens. A click in a detector, a tiny dot on a screen, a single event. Not a wave, not a particle in motion, an outcome. So what is light? Here is the most honest answer modern science allows us to give. Light is the way nature moves energy and information, but it does not move the way everyday objects move. Light is not a thing inside space. It is a rule that governs how events may occur, with what probability, and under what conditions. And this is why the question, is light a wave or a particle, is quietly misguided. It assumes reality must fit the categories our minds find comfortable. Nature never made that promise. Light teaches us something uncomfortable. Reality is not obliged to make sense intuitively. Science progresses not by confident answers, but by honest confusion. Every major breakthrough began with someone saying, "Something doesn't fit." So the next time someone asks, "What is light?" a truthful answer might be, "Light is not what we imagined," and understanding that is more important than forcing it into familiar shapes. And perhaps the real lesson is this: understanding science is not about knowing answers, but about learning how to think honestly when answers fail.